Hello everyone. Um, Today we're going to work with the module 11, which is the subject or the topic is thresholding with images. The agenda for today is just about thresholding, but I want to talk about a couple of things before that. It will be open, and it is open for your section, module 12. There are no module 12, two practices exams. There are the two parts for exam 2. They should be available for you. They are pretty simple, but again, that should give you an idea how the exam 2 is going to be. Draft. That's the idea. You have the first part with several questions, and the second part is a programming assignment. There's going to be a problem, some sort of working with like patterns or solving a problem, and then with images. That should give you a very good idea. Remember that our exam is coming November 19th. Here in this slide you can see the time and the classroom that we're going to be attending to, and after that we just have the thresholding. So I wanted also to give you the heads up about what we have. We are in week 11, which is here. So module 11 and 12 are open. Module 11 is the one that we are working right now. And homework for module 11, it will be open as well. Not homework for module 12, which is matrix concatenation. We won't be hosting or working with this module in class, so it will be open for you as an assignment. You need to use office hours, you need to see the videos, you need to solve this in your own time, because next week is holidays for this section, and then after that we have the exam. We don't have much time. After the exam we have holidays again, and then we meet a very last time in December at the beginning. That's why we have the semester is almost over. So about thresholding, image thresholding. So what we do here is we use a couple of techniques about getting a specific value for the pixels, or getting a region that we want to recognize. So given an image, and then if we want to find the pixels that match a particular color or particular RGB color, and then ignore the rest, that's very useful to get in, let's say, a puck, or getting a penny, or getting something like that. The way that we can do that is by converting the colors in black and white, or 1 and 0s. And here, for example, we are creating an image where everything is 0, and we can use also the instruction false height width, and that we will convert the 2D image, or a 2D image into black and white, just with 0s and 1. And that might be useful for you to pinpoint where a specific object or image is. How does that work? So here, for example, on the left, we got the epoch in image. That image consists of 3D matrices for the RGB colors for each one of the values for the pixels of the original image. And then if we convert this image into binary, you will have something similar to the image on the right, only the white and black stuff, which might be something, it might give you an easy way to find a specific object within the image. Here everything will be 0 for the black, and it will be 1 for the whites. So it will be like kind of easy to determine where an object is. Here also on the right, there's an example of image thresholding. the goal is to track the blue puck in the original image. It might be a little bit more complex than the actual problems that you're going to be conducting for this practice. But anyways, the first line is just reading the image or the expecting getting the input from the keyboard. Then you get to read the image in the variable named pics. You get the size for pics, getting the height, width, and color, and then we convert that image into the only zeros and one, making this using false. From there, there's this logic where we pinpoint the colors. We check if red is between 10 and 40, green it is between another range, and also we are just pinpointing in a specific color, checking every pixel to see if it matches something that we are looking for. And that's basically the logic that we are going to use for many of the things that we face in the mostly the last problem, because the first two are generating images. So here there's another example. Write a program to find the centroid of a puck. You can take some time to analyze these programs. Use the office hours, work with the peer mentors or so, but there are some comments and some explanation that you might find useful for the problems that you're going to be facing later on. So here also we got an image where there is a straight line in diagonal. So there is a code here on how to create the image and how to get this image to be displayed. There's the algorithm. Again, this is something that you can work slowly and analyze together with peer mentors. That might be a useful technique to use in the future problems. Finally, with that, we get to the problems, the three activities that we have. The first one usually is one of the easier ones. You need to draw an American flag. So we have red, white, and blue colors. The basic logic probably will be to draw or to create a rectangle, probably white, and then after that you create some sort of piece of code that can draw the red lines, the red strips to the specific width. And lastly, once you get that, you create the blue square to override the strips, the red strips that you had already. You can work more with the peer mentors about that. Activity B is a very interesting activity. This one you need to count how many pennies there are in a specific image. You are given some pennies or some images that has different amounts of pennies. For this one, what I recommend is you have penny alpha, penny bravo, and penny charlie that has 1, 2, or 3 pennies. What I recommend is that you go into penny alpha and count the amount of pixels that you have in one penny. That's a very good image there. I remember that the amount is close to 1800 or something like that. From there, then let's say that you go to penny bravo, that should be this image here. You need to pinpoint the color that is similar to a pixel. You will go one pixel at a time. You need to go over the whole image and count how many pixels are part of the penny. So if you check a pixel that is here and you confirm that it's black, you don't count that. If you come here some sort of gray or something, then you don't count that pixel as a penny. But once you get here, then the things get interesting. It is very difficult to get the color of a penny. I will tell you that you should evaluate several pixels and check for the trend, check for the ranges of the color. Probably you should be looking at the red color when you check that. I will do an example very quickly in MATLAB in a second, so you can know how to check the colors using MATLAB. You can do that in MATLAB online as well. Finally, here, usually I leave this in class, but those are the kind of things that you need to use. Let me go to MATLAB very quickly. MATLAB is here. Let's say that you start a program like this. This is a longer program, but what I want is just to create an image or to open an image. In your case, probably instead of creating one, you will go and open the Penny Bravo image. Here is just a black square. For us, it's not important. We can say continue and go to the end. Let me see what I have here. It's just the checkerboard. So what you can do when you have this in MATLAB is that you can go to tools and use data tips, and then when you go here and you click, you can see the RGB values. It will be 255, 255, and 255. That's white because that's what we did. If you go here, it will be 000. This is specific for this image that I created with those values. But when you open an image like Penny Bravo or so, you don't get perfect black or perfect whites. You will get values that are in between. So you need to do a conditional for checking red color, green color ranges, and from there is when you can check if a pixel is part of a penny. I hope that this explanation is some sort of helpful for you, and if not, peer mentors, go to the peer and talk with the peer mentors so to help you out. That you should be able to do it. Probably counting the pennies is the most difficult one, but yeah, that's what I had for you. Let's keep working in the problems. Remember to take the attendance, and I see you next time.